one from YLD, which is Hassy Veldstra, and he will talk today about shipping resilient and scalable applications with Node.js and Artillery.io. And then we'll have a short break after the first talk, and we'll have the second speaker, Sebastian Benz, who's a developer at Google, and he'll speak about AMP. So today we really want to thank Salesforce for arranging this amazing venue, and especially to Chantal from the events team who put a lot of hard work here. And yes, please use our hashtag LLM for pictures and comments, and we'll reshare everything. If you have any comments, please also leave on the meetup. We're looking to hold more events coming soon. And yes, thank you all, guys. Hope you enjoyed the session, and catch up with you later. Thank you.
So just a couple of quick words about myself. I'm a DevOps contractor selling my services to the highest bidder, which at the moment happens to be YLD, the organizers of this meetup. If you're a Node.js developer or a DevOps person and you're looking for interesting work, then they're definitely the people to speak to. Great bunch of people, very, very interesting project. So do that if you're in the market. So I'm a DevOps contractor / software developer. I'm particularly interested in resilience testing, fault-tolerant software, microservice-based architectures, chaos testing, and load testing. And I love load testing so much that I built my own tool to load test things. So Artillery.io is, as I said, a load testing toolkit. It's modern, so no clunky UIs from the 90s, has a nice CLI, works well with CI and is very scriptable. Batteries included, and it's optimized for developer happiness. So out of the box, it does a lot of things, but it's also very, very easy to get started with. And then there's almost no limit on what you can do with it. And it's open source under Mozilla public license too. And the main objective of Artillery is to help developers ship scalable, fault-tolerant, and resilient applications. What problems does Artillery solve? The two main problems that Artillery tries to tackle are one, I've got a software system and I want to see how it reacts to load. I want to understand it better. And what that usually means is you want to identify bottlenecks in your system in terms of resource usage, so things like CPU, memory, database connections, that sort of thing. You'd usually express that in a metric such as requests per second, or maybe transactions per second, or queries per second. Different people use different terms depending on the kind of system they work on. And you also probably want to understand how your dependencies scale. So those could be microservices, other microservices in the system that your microservice talks to. They could be external APIs and partner APIs, or they could be things like MySQL databases. And then the other problem is you want to prepare your system for higher load. So there might be a high traffic day coming up, such as Black Friday, for example, if you run an e-commerce website, and you know that your traffic will double. So how do you make sure that your system is ready for it? You could cross your fingers and hope that things will be okay on the day and do nothing, or you could load test it and then find bottlenecks, fix them, and be confident that things will be okay on the big day. When I say system here, I mean something reasonably complex. So a good example is an e-commerce backend for an e-commerce website. So something with the concept of, say, user flows, and not just kind of simple request-response type of applications. There's a few other sort of smaller problems that Artillery aims to solve, such as I need to do load testing. If you're familiar with load testing, but you don't like JMeter, a lot of people don't. JMeter is probably the most popular load testing framework. Maybe do a quick poll. People use JMeter in the audience. Yeah, quite a few hands. So yeah, JMeter can do a lot. It's been around for ages. A lot of people know it, but it's quite clunky. It's written in Java. It's got a UI from the 90s, which requires a lot of clicking to do anything. It's not very easy to start with. It's something that I used quite a lot. Didn't really enjoy using, so I built Artillery. You want something that's written in Node.js, perhaps, as a Node.js developer. Something that you can easily install anywhere with NPM. Something that you can read the code for and understand better, and also something that you can script in JavaScript. And the fact, the fact that it's JavaScript and NPM also puts the power of the entire repository of NPM modules at your fingertips when you're writing load tests with Artillery, which is great because there's a module to do pretty much anything in NPM. Yeah, another problem is you might have a WebSocket or Socket.io-based application. JMeter supports WebSockets. A couple of other load testing frameworks support WebSockets with some caveats. Nothing else, as far as I know, supports Socket.io, which is a very popular framework for building real-time applications. So if you need to test that, your only option is Artillery. And then Artillery makes a couple of choices which sometimes need to be explained because they're not entirely obvious. But that's the wrong slide. That's the one. So Artillery optimizes being understandable and readable by anyone, whether they are a JavaScript developer or maybe they're on a QA team, so they've got some development experience, but they're not a full-time developer. SRE, which stands for Site Reliability Engineers, so they're the ops people that keep systems up. They can use Artillery too, and the main reason for that is that your test scripts are not written in JavaScript. They're written in very easy to read YAML, which you can literally look at and see exactly what happens, and we'll look at examples. And that, in my experience, makes a huge difference, because you're a JavaScript developer, you're very comfortable with the language, you can dive into a code base, read it very quickly, and understand what happens. But someone who's experienced in Ruby, who needs to do load testing, maybe work with the scripts that you wrote, they don't necessarily have the same level of comfort with JavaScript. And then the flip side of that as well, I suppose, is that if you take a developer, then the chances that they know JavaScript as opposed to some other language are the highest. So if you take a developer, it's more likely than anything else that they know JavaScript as opposed to, say, Python or Java or Scala. So yeah, Artillery is a reasonably young project. It's been around for just over a year and a half. Some of the users there, Ministry of Justice, have a team that use Artillery, Apigee, Autodesk. So they actually have open source projects with bundled in load testing scripts on GitHub. So if you do a search, they come up. LifeX, which is a company producing connected light bulbs. They're the biggest competitor in that market to Philips. They use Artillery to load test all of their systems, and they actually contributed some code to Artillery as well. Nordstrom, which is a massive retailer in the States, they're very heavy users of Artillery. They developed and published 3 plugins for Artillery, which is great. Rockwell Automation, probably nobody in this room has heard of them, but they're a $4 billion a year company in the States doing industrial automation. So they've got an IoT project using Artillery. Zero, SolarWinds, again, the name might not ring a bell, but they own Pingdom and Librato and Papertrail, which are great products, and loads more. There are some companies that I cannot name, all sorts of markets, and it's picking up. The community is also quite active. There's 45 contributors to date to open source Artillery. There's a bunch of plugins, mostly integrations with things like TeamCity and Datadog and InfluxDB, etc. Someone wrote a traffic recorder, a proxy that you run locally, and then put your web traffic through it, and it generates Artillery scripts for you. There's a similar thing in JMeter, so it's great to have that for Artillery as well. And there's also a Postman. Are people familiar with Postman? To Artillery converter as well that someone built. So if you've got your Postman collection, I think they're called, you can use that tool to convert it to an Artillery load testing script. And that brings me to my first demo. So Just going to jump in and see what artillery actually looks like. Where's my mouse? So the first thing that we would have done would have been to install artillery. I've got it already, so I'm not going to do that. And then the next thing we can do is run a secret command, which is not, it's kind of documented, but not really. Just to verify that the installation is working. That's a really terrible dinosaur. They change depending on the day. Yeah, we'll get the same one, but there's a few of them, so install it, have a play, check that tomorrow, it'll be a different one. So yeah, artillery is there, it's working, and we can run a quick test using the quick command. Oh, tricky. So maybe what I'll do is I'll just run artillery-help so that we can see what it can do. So you've got the run command, which runs a full-on script. There's the quick command, which lets you run quick ad hoc tests in a way that's similar to A/B, which I presume some people are familiar with. And then you can generate HTML reports. You can convert between YAML and JSON. We don't need to pay attention to that right now. Oh, Dino's actually there. Anyway, if we run a quick test with artillery now, so this will create 10 connections to artillery's website, and then on each one of those connections, we'll send 50 GET requests to the root path. So if we do that, it goes off and it starts running, and it will print a report every 10 seconds while the test is running to the screen. So we can see that things are happening, and we'll go through what each one of those things mean in a bit. But this is how easy it is to get started with artillery for something really, really simple. I'm just going to jump back into Keynote quickly. Okay, so we saw that. This is quite important if you're not familiar with load testing, because it's not always intuitive. But this is not unique to artillery. This is how JMeter works as well, and other tools like Gatling and Locust. So, say we have an API, and we will have users that arrive to use our API. Each user then, the proper way to call those users are virtual users, because that's what artillery simulates. But just to make it easier to say things, I'm just going to call them users. So each one of those users will execute a scenario, which is a sequence of steps that interact with the API. So there'll be, if we're testing an HTTP-based API, there'll be get and post and delete and whatever calls to it. And those users arrive in phases, and each phase has a duration and an arrival rate. So an example would be a phase that lasts 10 seconds, and you get 10 new users arriving every second. So you'll get 100 users in total over that 10 seconds. And then how that will map onto requests will depend on the sequence of steps that you've got defined in your scenario. And each user is completely independent of all other users, just like in the real world. And the total duration of a load test is the duration of the phases, and then plus the time that it takes for all users to complete their scenarios. So you can have a scenario that lasts 10 minutes. So then when your load phase, for example, is 5 minutes long, the entire duration of your test will be at least 15 minutes. It could be longer. It depends on how quick your the backend is that's being tested. And yeah, the point of that is to model load realistically and similar to how things are in the real world. Users will keep arriving regardless of whether other users have finished or not, and regardless of how quick or how slow the API is. And individual users will usually execute their scenarios sequentially for HTTP, because in most scenarios, unless you're testing a web server, you want to have the result of one request before you send on another request. Yeah, there's a style there, a small print. If you're testing Socket.io, then you might want to send async messages, that is, send a message and then not wait for anything to come back and then send another one. Yeah, and by default, each user will map to a new TCP connection. But again, to small print, that's configurable. So for HTTP, for example, if you're testing a a load balancer, then you definitely want a new connection for every virtual user, because again, that's how things are in the real world. But if you're going directly to a microservice, then you probably want to have a socket pool of a fixed size, because you want to simulate how requests would arrive from the load balancer to your microservice. And there would usually be a fixed number of connections. So Artillery gives you the flexibility to model things to fit what you're testing in. The situation that your target is in. So we'll run another quick demo, and those are just the things that we'll go through. So we ran the quick test, which sent 50 GET requests on 10 connections. And what happens behind the scenes when you run a quick test like that is Artillery actually generates a full-on script file behind the scenes and then runs that. And this is what it would have generated behind the scenes. So each Artillery test script has two sections. It's got a configuration section where you define things like the target that you're testing, and then here we can see a load phase definition. So we have 10 connections, i.e. 10 users, and then duration is 1 because we kind of launched them all at the same time. And then in the scenario section, you can have one or more scenarios which describe how a typical user would interact or could interact with the system. And in our case, we're just looping 50 times, and all we're doing is sending a GET request to that URL. So that's pretty simple, I hope. Any questions? Yeah?
How you could test specifically secure endpoints where you require, for example, token?
That depends on where that token comes from. So if you have we're actually going to cover that later. If there's an endpoint that lets you authenticate, then you can, as part of your scenario, you can authenticate and then reuse that token in subsequent requests. But yeah, that exact example is coming later. So I'm going to run that now instead of. Nope. Okay. So now instead of using the quick command, we use the run command, and then we give it that YAML file, and it will go off and run the exact same test again. So we'll let it finish. As we can see there, Artillery generates a JSON file for each run, and that contains information about the test. That's really useful for creating custom reports, for example. So if we look at part of that file, we can see that the information that we see in the report is in that JSON file, but then it also includes detailed stats for each request that was made. So the interesting bit here is how we read this. So Artillery by default does not report averages, because averages are useless when you're doing load testing. Usually what you want to be looking at are percentiles, so especially the 99th and the 95th percentile. People familiar with what that means? Yeah? So a 99th percentile of 299 milliseconds means that 99% of all requests completed in that amount of time or less. So 1% of requests-ish took longer than that. So that's pretty good. So we're seeing percentiles, minimum, maximum values as well for requests, and then also for scenarios. So this can be useful if you have a longer scenario and want to see the distribution of how long that takes. And we see that we got 500, 200 OK status codes back. So when you run those tests, usually interactively, what you want to look at is these, and you want to see the change in these values as the test progresses. Because if these start growing, then you know that the system, the target, is becoming overloaded. And then we didn't have any network errors or anything like that in here, but they would have been reported down here as well. So timeouts or reset connections get reported under there. And then we'll just have a quick look at the HTML file that Artillery can generate from the JSON file. We'll do that one. It opens in my browser, so there's not much to look at here because there's not much data, because we only ran for 10 seconds, but you get nice charts of the numbers that we saw in the terminal output. yeah, usually you have kind of nicer lines here. But yeah, these can be useful to publish somewhere as part of your CI pipeline for people to look at. Okay, cool. Let me go. Yeah, cover that. Yeah, in terms of features, we saw that we can send GET requests. That's cool, but it's probably not very useful if that's all we can do. We can use other HTTP verbs if we want to. With payloads, obviously, we can send headers, custom headers. Cookies are supported, so if a server replies with a cookie, then that virtual user will remember it and automatically reuse it in subsequent requests. We can do forms, and we can do request chaining, which is second most powerful feature in Artillery. And what request chaining is it lets you make your scenarios dynamic. Artillery has a concept of variables, that is things that vary inside your scenarios. So things that can vary inside payloads or URLs, for example, that the virtual users are requesting. One example would be, again, an e-commerce user journey. So in your scenario, for example, a user could arrive to the homepage. So that would be step number one. Step number two, a user could search for a keyword, a product, and that would be a variable, which could come from an external CSV file, for example, which could define loads of keywords to use. They would get some response back. Let's say it's JSON. And out of that, they could grab an ID of a product, store that as a variable, and then use that to make a request to that product's page. Get to the product's page, and then maybe add that product to cart, and then go through the checkout flow. And we'll look at a simple example of logging in. Can you see that at the back? Is that okay? Yeah. Yeah, so this would be one of the steps in a scenario. So we're sending a post request to /session. We're sending along some JSON payload. Username is Hassy. Password is London Node.JS meetup. And then we use this capture spec, which is a part of Artillery. And we're saying that we're expecting JSON to come back, and then we're using a JSON path expression to grab the value of a field called access token at the top level of the object that comes back, and then we store that as a user variable called access token. And from that point onwards, we can use that variable in this manner, for example. So if this was after the previous request in a scenario, we could then make a GET request to a protected endpoint, and we could send that token in the authorization header. So was that, yeah, cool. Any questions at this point? Yeah?
So what happens when you do CEO optimization and you don't send JSON back and send plain HTML directly to the server all the time?
You can parse HTML as well. If that's what comes back, you can parse XML as well with XPath. And you can also do regular expressions. And then if none of those work for you for some reason, you can write a custom JavaScript function to extract whatever you need, and then basically use it in the same manner. Yep. That conveniently brings me to what are called hook functions in Artillery, and those are those little snippets of JavaScript that you can make your users call to do things. So the way that works is you write a Node.js module which exports a bunch of functions, which Artillery then loads at runtime. And any exported function is available to your scenario. Some of the extension points that are supported are before scenario and after scenario. So you can run a JavaScript function before a virtual user kicks off their run through a scenario. In the HTTP engine, you can do before request and after response hooks. So before request lets you modify what gets sent if you need to before the payload is actually sent, and then after response provides you access with the response from the server. So that includes headers and body, and you can do things with that. And you can also call custom JavaScript as a step anywhere in the scenario. There's going to be an example And these are useful for generating randomized data, for example, for your test with something like Faker or Chance. So you don't need to hard code any of the values in your test scripts. You can also abort the test early for some reason if you need to, if some condition doesn't hold. You can make calls to external services to fetch some information that the virtual user might need. As I mentioned, you can require any NPM module in in the module that provides your hook functions, so you can pretty much do anything. So one of the examples, I'm not going to go through the entire thing, but there's a blog post on Artillery's website which shows you how to use Faker.js to send randomized data. I've got it loaded here somewhere. Yeah. Let's make that slightly bigger. Yeah, so this is a slightly more complex scenario here. So what we're doing is, yeah, that's obviously a made-up target. We've got two phases, 1 minute and 10 minutes. This is how we tell Artillery to load a module with your custom functions. And then we've got one scenario, and our step one calls a function called generate random data, which is defined there. And that function, so this is our module. We export that one function, nothing else. We require Faker, and then inside there we generate a first name, an email address, a password, and then this function has access to that specific user's context, so we can insert those values as variables into the context. So they will be available as variables, name, email, and password. And those are the variables that we're using here in the JSON payload. So we say name is name, email, etc. And that's that. Any questions about this? No? Cool. This is explained in more detail on the blog if you're interested. Yes. No. Okay, just a quick word about performance of Artillery itself. It's got multi-core support, so it'll make use of every CPU that you've got on your machine. It's experimental still. It's behind the feature flag, but it's usable. So in very unscientific benchmarks that I did last year, you could do around 1,600 requests per second on a 2.4 gigahertz Intel Atom C2550, which is not meant to be a very performant CPU. So, you know, it's quite good. It's not the most performant load generator perhaps because it's written in Node, but it's plenty fast for most applications. And because Artillery is so easy to install, it's actually pretty straightforward to set up a cluster of EC2 instances to do proper distributed load testing if you need really, really large scale. And that brings me to another demo. We looked at HTTP, but as I said, Artillery does other protocols too. And what we're going to do here is, so in this tab, I've got a chat application running. It's an example app that comes with Socket.io. So it's running there. We don't need to look at that. But we're going to load test it. And this is the load testing script that we've got. So I'm just going to quickly go through it. So the target is running on the same machine. We've got two phases. They both last only 10 seconds. But in the first one, we'll get one user every second, and that's meant to be the warm-up phase. And then the other phase is 5 users per second, and that's meant to be, you know, serious load phase. This feature lets us define sort of a static list of variables that will be available to the scenarios without having to, you know, generate them in JavaScript or load an external CSV file. So they're just a bunch of strings. Then we're loading a Node.js module for custom functions. And then in this script, we've got 3 scenarios defined. So the first one, and this makes use of a feature in Artillery that lets you weigh different scenarios in your test script. So in any given chat room, most people will be lurking and not really doing anything. So in the scenario that emulates that, we assign a weight of 75 to it, which means that most of the users generated by Artillery when it runs this script will be of this type, roughly 75%. So what else do we do here? We set the engine to be socket IO because by default Artillery will pick HTTP, and it can't guess from the target here that it's socket IO because it's also HTTP there. We go to the home page, and then we use app-specific actions, I guess. So we join is name lurker and then a random string, and then we just hang around for 60 seconds and then disconnect and leave. Then we've got a mostly quiet user. So we'll have roughly 15% of users will be of that type. And that user goes to the home page, joins, and then sends one message, hangs around for 60 seconds, and then leaves. And then we've got a very chatty user. So there's not going to be a lot of them, but they will be sending a lot of messages. They'll be sending 10 messages, each of them, and then, again, hanging around for about 60 seconds and leaving. So this is the application. So I'm just gonna join the chat room. What's your nickname? Hassy. I'm in the chat room. There's no one else. Hello. No one's going to say anything back. What we're going to do now, we're going to run this, and then things should happen. Actually, I think I've got a npm script defined. Yeah, cool. So I can just do npm run load. Boom, off it goes. Doing its thing. So if we go back to the chat room now, we're seeing people are starting to join. Oh, I forgot to load up the JavaScript file that actually generates the messages that get sent. But yeah, we can see that users are joining, doing things. We don't really need to wait for this entire test to finish because it's going to take another 60 seconds. But we can abort Artillery there, and then we see that everybody's gone, and it's just myself again. Any questions? No, cool. Okay, so that's kind of it for Artillery itself. Just a few words on sort of what I would do if I needed to prepare that chat application for high load. For some reason, I was going to put it in production. Thing number one, you'd set up a test environment. So this could be something that is a replica of the eventual production environment, but you could also, for some situations, your test environment can be your laptop. So if, for example, you want to see if the application has memory leaks under load, then you don't necessarily need to deploy it on AWS, for example. You can run it locally, throw some load at it, and then monitor it with something like heap dump and see, sorry, not monitor it with like something like heap dump, but watch its memory usage. And then if you see it growing, you can use something like heap dump to actually get heap snapshots and then compare them and see where memory is being leaked. Step number two would be to set up monitoring. So when you're doing load testing, you really cannot have too much visibility. You want visibility into every layer of your stack. So you'd start at the bottom with sort of base level monitoring of infrastructure. So those are all AWS terms because it's what I'm familiar with the most. But you'd want your EC2 VM metrics, things like CPU usage. If you're running on ECS, which is the container orchestration solution from AWS, you'd want metrics for that, like how much CPU are you using versus how much CPU is reserved. You'd want metrics from your load balancers. If you're using any external databases like RDS MySQL, for example, you definitely want metrics from those as well. Again, CPU usage, number of connections, that kind of stuff. Datadog is something that I've used a lot. People familiar with Datadog? It's a great monitoring solution with AWS. You just plug it in and it kind of ingests a lot of stuff from metrics generated by AWS, so you don't even need to install anything. You can install Datadog agents to get more metrics, but it's pretty good by default. No affiliation, by the way, just happy user. You'd want an application performance monitoring solution as well. One I'm familiar with the most is New Relic. People familiar with New Relic? Yeah, cool. So that's most people in the audience, but yeah, you definitely want that to be able to see, what a particular handler is doing. And then you'd also want to connect Artillery to whatever monitoring solution you end up setting up, so that you can see metrics from Artillery on the same dashboards and the same graphs as performance metrics from the application and the infrastructure. And Artillery has plugins to connect to Datadog, Influx, and it comes with StatsD support out of the box, and pretty much anything speaks StatsD protocol. So you can send Artillery metrics to pretty much anything. And in terms of methodology, it usually doesn't pay off to kind of jump in and just start running load tests without having a clear idea of what you're trying to figure out. So it always helps to formulate your high-level objectives, and then also, before you run an individual test, to kind of keep in mind either a hypothesis that you have about the performance of the system, what you expect to see, or a question that you're trying to answer. Keeping a log is something that I find very useful, so that's literally a text file where, before you run a test, you write down the exact setup of the infrastructure, and then your test scripts should probably be in source control. If they're on GitHub, say, then you can link to the exact commit of the test script that you are about to run. And yeah, it's always good to share the findings with the rest of your team to help knowledge spread. Say you're ready for high load. How do you stay prepared? You have to load test regularly. Make your CI server do its job. The two strategies that people use most often are you either run load tests every time you deploy to a certain environment, like staging or UAT or whatever, or you run your load test on a schedule. So, for example, every night, or every night on a Friday, whatever. The key there is that you do it regularly, so that you don't introduce performance regressions that then come back or appear later and surprise you. And then if you want to get really, really advanced, then you try to work to a point where you load test your production system. And this, I'm not going to go into this too much, but it can sound really scary, but it can be done in a very safe manner, and it can pay huge dividends, because if you're able to work up to a point where you can run a load test which adds, say, 20% extra traffic to your system at peak time, then at any given point you know that you can take extra 20% in traffic, and it gives you a lot of confidence in not just your code, but also your infrastructure, your logging, your monitoring, and your processes as well. Because to get to a point where you're able to load test production, you really need to work across the organization. And if you're able to do that, that's always a good sign. And then just a couple of words about other things that go well with Artillery / load testing in general. Chrome DevTools, amazing tool. Combining the two lets you achieve full stack JavaScript performance, because you can use Chrome DevTools to optimize the front end of your website, and then Artillery to optimize the back end. Chaos Lambda is another little open source tool that I built. And it's a serverless implementation of Netflix Chaos Monkey that runs on AWS Lambda. So super easy to set up. You literally npm install it and then deploy it to your AWS account, and it will do its thing. I forgot to put the quote in there, but there's a great book that recently came out by Susan Fowler, who is a site reliability engineer at Uber, and it's called Production Ready Microservices. I recommend that everybody gets that book. It's basically a giant checklist of things that you need to do to put a microservice-based system into production safely and with confidence that it's going to be highly available and scalable. And she defines fault tolerance as code testing, which means things like unit testing and linting your code, and then load testing and chaos testing. So Artillery and Chaos Lambda let you achieve those last two things on that list. And that brings me to the end of my talk. So check out Artillery. That link there is a link to Chaos Lambda. You can also just npm install chaos-lambda and have a go. And yeah, if anyone has any questions, happy to answer them. Yep.
How easy is it to write like a new like transport protocol? So you've got like software. How easy is it to add it on?
It's very easy. Yeah, it's very easy. We literally just the other day published an engine, they're called an engine, which lets you load test AWS Kinesis. And the entire thing is maybe 50 lines of code. So Artillery has a well-defined, not well-documented, well-defined interface, which allows you to plug in another engine. And then, yeah, again, Node and NPM are great. There's a Node module for pretty much any protocol. So yeah, it's quite easy to hook things in. I can maybe quickly show it. Yeah, if you go to Artillery's website and then the blog, the top post. Oh. Blog. Yeah, so this will have a link to the plugin, and you can check out the code. Yeah, it's very small. Yeah, please.
You mentioned doing distributed tests. How do you go about, say, you want to run Artillery on 4 nodes on the same website simultaneously? Is that something you script yourself, or does Artillery provide?
It's something that you have to script yourself right now. I'm working on a distributed mode that will work with AWS to start with, just because it's easy. But
something to do that.
yeah, right now you'd write an Ansible playbook or maybe a CloudFormation template to spin up those instances and then run Artillery on them. And then probably set up, say, a Datadog reporter so that you get your metrics from every node into a central location. Yeah. Yeah.
Earlier you mentioned JDBoss.
Yeah.
How easy would it be to migrate from a bunch of test scripts and test scenarios in JDBoss?
Good question. I don't really know. I guess it depends on how complex they are. I know there have been a lot of people, and I'm going just on. There's a Gitter chat room and people ask questions. There have been a lot of people that have migrated from JMeter to Artillery, but I don't really know how complex their scripts were or how long it took. I'd say it's definitely possible, but the time investment that you will need really depends on what your test scripts are doing. Yeah.
How easy would it be to integrate this with the most common test runners in JavaScript like Mocha or Jasmine?
Again, I know that people have done that, but I don't really, I haven't done it myself. I suppose Artillery does expose its commands, like the run command. You can require Artillery and then use that command in a Node module. So it's definitely possible, probably fairly straightforward, but I haven't done it myself. Yeah.
If you wanted to have a look at the data afterwards, can you get does the export in JSON, does that include each of the requests?
It does, yeah.
Does that include also differentiate between things like the HTTP time versus TLS time?
No, you just get the entire time it took for a request to be sent, processed, and then come back. But there's a plugin for Artillery which will look at X response time header or another header like that, and then extract that value and report that as latency measurement instead of the measurement that also takes in the network transfer time. Yeah.
Is it possible to configure timeouts and retry behavior per request, or is it a global scenario thing?
Timeouts, yeah, they're global, so you can configure that. Actually, no, that's not true. You can do per request timeouts as well. Yeah. So that would be, if you have a global timeout setting, that will get applied to every request unless you overwrite it in an individual request. Retry behavior, Artillery does not support yet. Yeah, some people have requested that feature, but no one's contributed any code yet. But there's nothing that would prevent Artillery from being able to do that. There's a question at the back somewhere. Nope. Oh yeah.
How much trouble did you have doing this kind of mathematical analysis in JavaScript? Was it easy?
Again, NPM is amazing. I just grabbed the module that does it. Yeah. Yeah, nothing else to say really. Yeah.
Question about stats. Can you, so the way the stats would give you the whole scenario,
Mhm.
can you break it down to requests? If you have a scenario that goes through several steps,
Yep.
have a look how long.
Oh, each of the steps. So that's not possible out of the box yet. You can do it with custom JavaScript. There's a snippet of code in floating around that shows you how to do that, but it will be a built-in feature in one of the upcoming releases as well, because it's something that pretty much everybody wants. So yeah, it's possible now with a tiny bit of custom JavaScript, and it's coming. It'll be built into Artillery soon enough.
One other question. So, for example, with WebSockets or Socket.io, is it possible to have kind of a background cron sort of task that would run during the scenario? So, for example, you might have some sort of ping every 30 seconds to avoid a load balancer connection timeout.
Mm-hmm.
Is it possible to have that and then continue with a linear set of steps as well?
Not right now, but it's on the roadmap as well. Yeah, it's a very common use case. Yeah. Yep.
Are there any tools to compare two reports, for example, between builds, so you know like the percentage change?
Yeah, no, but that's one of the things that you could do with those JSON logs. Yeah, so I've scripted something like that myself using JQ and some shell scripts. But yeah, no, nothing out of the box yet. Any more questions? No, great, thank you.